Alright, so we're continuing our journey towards a better understanding of the base 12 version of pi by looking at this diagram that generates all 360 degrees using base 12 geometry. In past videos I've shown you how the Cartesian plane in base 12 is a denser grid than in base 10, and I've also introduced you to the base 12 dodecagon, which also has a different relationship to the one in base 12 than it does in base 10 because of the denser grid. So all these different factors of base 12 versus base 10 are culminating in this diagram and eventually into a better understanding of the base 12 version of pi. What we're going to do in this video is take a break from all the rings of this diagram and just look at the equation that's been in a way lurking beneath all this geometry, which is dividing the diameter of the dodecagon into its perimeter, which is ultimately becoming the circumference of the circle. So we can use any combination of diameter and perimeter, but I think we can just go to the very first inner ring of the dodecagon, the first pattern in the series, where the diameter is 1.7 root 2 and its perimeter is 5 root 2, and we can just do that equation. We'll do that for this video, dividing 5 by 1.7. So we can kind of dispense with the square root of 2. We can remember that's the root of the equation, but we can take that square root of 2 out of there and just do the equation 5 divided by 1.7, and let's see what we get. You can see we're just going to write it out as 1.7 divided into 5, and then we're going to move the decimal place over, so it's 17 into 50, and we see that that goes 3 times. So 3 times 17 is 49, so we have a remainder of 3. So we bring down the 0. 17 into 30 goes once, so 1 times 17 is 17, with a remainder of 15. We bring down the 0. 17 into 150 goes a times. Again, we're using base 12 math, so a times 17 is 13a. So 13a from 150 is 12. We bring down the 0, that's 120. So 8 times 17 is 108. We have a remainder of 14. Bring down the 0. So again, a times 17 is 13a. We have a remainder of 2. So 2, bring down the 0, 20. 17 goes into 20 once. 1 times 17. 17 from 20 is 5, bring down the 0, and now we have a 50 again. So we're back where we started. 3 times 17 is 49, remainder 3, and now we see we have a repeating decimal. So just write that out again, put a line over the top. So that's the answer to the equation, 5 divided by 17 in base 12. So in the next video, we'll go over the other version of that equation where we convert everything to their square roots and then do the same thing, another long division equation. So I hope you can join me for that video. Thanks for watching.